Imagine standing in a silent desert at night, the sky above you bursting with stars. Before you stretches a cosmic ocean, millions, perhaps billions of points of light, each representing suns beyond counting, unseen planets, and mysteries yet to be uncovered. Since the dawn of humanity, we've gazed upward and asked, what's out there? Are we alone? How does the universe work? These questions have fueled curiosity for thousands of years, from ancient astronomers charting the heavens to modern telescopes peering to the very edge of the cosmos. NBUT, what makes the universe truly astonishing is that every time we find an answer, we end up with an even bigger question. Now there are things so strange, so mind-bending that the laws of physics we learned in school feel like only half the story. Today, you and I will explore 10 extraordinary cosmic discoveries you may. In 2019, the Hubble Space Telescope captured something that forever changed our perspective on life beyond Earth. Water vapor in the atmosphere of an exoplanet called K2-18b. This planet sits in its star's habitable zone, a region where temperatures are just right for liquid water to exist. NWHY, is this important? Because water is one of the fundamental ingredients for life as we know it. NIF, there's water vapor in the atmosphere. There could very well be vast oceans on the surface. NNBUT, hold on, K2-18b isn't exactly Earth 2.0. It's about 2.6 times larger than Earth, and its gravity would make movement difficult for us. Its atmosphere might also contain gases toxic to humans. Still, for other forms of life, perhaps alien microbes, it could be the perfect home. And imagine one day future telescopes like the James Webb Space Telescope or Nancy Grace Roman detecting signs of life there. NNOT, just light and shadow, but actual chemical fingerprints. Oxygen, methane, even complex molecules. NNIF, that day comes, history will record it as a turning point. No longer will we ask, are we alone? But rather, what do our cosmic neighbors look like? In the universe, the death of a star usually means a spectacular supernova explosion, leaving behind a dense core like a neutron star or a black hole. NBUT, there's a bizarre kind of star called a zombie star that seems to refuse death, and one example is a half-done type EA supernova. Normally, these explosions obliterate the entire star, but astronomers have found cases where only part of the star is destroyed, and the remaining core continues to shine. Like a monster from a horror film, this star comes back to life, radiating light long after it should have been gone. This phenomenon isn't just strange, it's important to cosmology. Type Ia supernovae are often used to measure cosmic distances, and the discovery of zombie stars forces scientists to reconsider those measurements. NIF. We've been calculating distances based on flawed assumptions. Our entire map of the universe's scale could shift. Think of these zombie stars like candles that have exploded, but somehow, the wick is still burning. They are a reminder that in the universe, death doesn't always mean the end. Imagine standing under a dark cloud, not of water, but of shimmering diamonds. Deep inside giant planets like Neptune and Uranus, immense pressure transforms carbon into crystal, creating diamond rain. And laboratory experiments here on Earth have confirmed this. By replicating the extreme pressures inside these planets, scientists have turned carbon-rich materials into tiny diamonds in just seconds. This means that in the depths of Neptune, diamond storms could be happening every single day for billions of years. This phenomenon isn't just beautiful, it offers clues about how planets form and evolve. If we ever send a probe to Neptune, we might one day witness glittering jewels falling through a methane sea. Picture a black hole, the most destructive object in the cosmos, yet smaller than an atom, but with the mass of a mountain. These are ultra-lightweight black holes, possible relics from the dawn of the universe. Unlike ordinary black holes formed by dying stars, these could have emerged from quantum energy fluctuations moments after the Big Bang. If true, they might act as cosmic fossils holding secrets about the earliest conditions of reality. Some scientists even suspect these tiny black holes could make up part of dark matter. Thankfully, there's no evidence they're lurking nearby. Still, The idea that space could be peppered with countless invisible mini black holes is both unsettling and fascinating. We see stars, planets, and galaxies, but they make up only a small fraction of the universe's true content. Roughly 85% of the universe's mass is dark matter, something that doesn't emit or reflect light and can't be seen. NHOW. Do we know it's there? Through gravity. Galaxies spin faster than they should, as if held together by an invisible hand. And clusters of dark matter also form a cosmic web, a colossal framework that shapes the structure of the universe. Despite decades of study, we still don't know what dark matter is. Its particles could be as old as the Big Bang, or older. Discovering its true nature would be one of science's greatest achievements, because it would mean we finally understand the majority of the universe we live in. In 2015, the LIGO Observatory detected something Einstein had predicted a century earlier: gravitational waves, tiny ripples in spacetime, created when two black holes collided. This discovery opened an entirely new sense for astronomy. Until then, we could only study the universe through light, whether visible, radio, or infrared. Now, we can listen to the universe through the vibrations of space-time itself. Gravitational waves allow us to observe cosmic events too dark to see, such as the mergers of neutron stars or the collapse of stellar cores. Each detection is like hearing a faint, deep tone from across the cosmos, a signature of a cataclysm we'd otherwise never know happened. In the future, more advanced gravitational wave detectors will give us a sound map of the universe. And who knows? We might discover events so strange that even our wildest theories won't be enough to explain them. Not all planets orbit stars. Some are rogue planets, worlds drifting alone through interstellar darkness without a sun to warm them. They may have formed around stars but were flung away by gravitational interactions, or they may have formed entirely on their own from collapsing clouds of gas. And although they float in eternal night, large rogue planets might still have internal heat, enough to keep oceans hidden beneath thick layers of ice. Imagine a warm ocean, far from any star, home to strange life forms that have never seen daylight. These worlds challenge our assumptions about if the sun were the size of a basketball, UY Scuti would be as large as a football stadium. This red supergiant star has a radius roughly 1/700 times that of the sun. If it replaced our sun, its surface would extend beyond Jupiter's orbit. Despite its immense size, UY Scuti is in the final stages of its life. Stars this massive burn their fuel quickly, and someday, UY Scuti will explode as a supernova, or perhaps an even more powerful hypernova. Studying UY Scuti helps astronomers understand the life cycles of massive stars, and it serves as a humbling reminder. In the grand scale of the cosmos, Earth is a mere speck. In 2007, astronomers detected a millisecond-long flash of radio waves from outside our galaxy. This was the first fast radio burst, or FRB, a phenomenon that lasts less than the blink of an eye but releases as much energy as the sun does in days. NNW, here do they come from? Some have been traced to magnetars, neutron stars with magnetic fields trillions of times stronger than Earth's. But others repeat at odd intervals, leading some to speculate about extraterrestrial technology. Nutreo date, hundreds of FRBs have been recorded, yet the origins of many remain a mystery. Whatever the explanation, FRBs are proof that the universe still has surprises powerful enough to baffle even the best minds in science. At the heart of our Milky Way lies Sagittarius A, a supermassive black hole with the mass of 4 million suns. While ours is relatively quiet, in other galaxies these giants blaze with incredible energy, creating phenomena known as quasars. Quasars are so luminous they can outshine the entire galaxy around them. Their power comes from matter falling into the black hole at near-light speeds, generating jets of particles that shoot out into space for thousands of light years. And studying quasars gives us a glimpse into the early universe, when galaxies were young and their central black holes were still growing ravenously. They also serve as cosmic lighthouses, visible across billions of light years, guiding our understanding of the universe's distant past. From alien oceans to the largest known star, from ripples in space-time to storms of diamonds, each of these discoveries pulls back the curtain on the universe's grandest secrets. And yet, the more we learn, the clearer it becomes. We've only scratched the surface. NTHE Cosmos isn't just a collection of stars and planets. It's a vast laboratory where the laws of physics are tested, where mysteries are born, and where wonders beyond our imagination are waiting to be found. NSO the next time. And maybe, just maybe, you'll be part of the generation that discovers them.